I want to look at two more examples where we need to find the inverse function of a given function. We're also going to find the domain and the range of the function and its inverse, and then we're going to graph the function and its inverse. So we already did problems 52 and 56, and now we're going to look at problems 58 and 62. So for problem 58, we have that f of x is equal to x squared plus 9, and we're restricting the domain to x greater than or equal to 0. And the reason for that is if we graph this function, x squared plus 9, well, x squared is a parabola, and we shift it up 9 units. So let's say this is about 9. So it's going to look like, we do it with a different color here. It's going to look something like this. But the problem is this function is not one-to-one. And because it's not one-to-one, it's not invertible. But if we get rid of part of the graph, you can decide to get rid of the part that's greater than 0 or less than 0. And for our purpose here, we're saying x is greater than or equal to 0. So if we get rid of this part of the graph, then this is a one-to-one function. So it's just half a parabola. Now if we graph the line y is equal to x, right here, in fact, maybe I can move this down just a little bit. There we go. Because we need this line y is equal to x to help us graph the inverse. Now, maybe you can go ahead and see what the inverse of this function is going to look like, because remember, it's symmetric with respect to this line. So we're going to go through 9 here, and it's going to look something like that, but kind of off to the side like that. Okay, so now that we have an idea of the graph, let's start finding the function, the inverse function. So what we do is we set this equal to y, and then we switch the roles of x and y. So we have x is equal to y squared plus 9. Then we try to solve for y. So if we subtract 9 from both sides, and then take the square root, right here I'm going to write this for a second, but this is not the answer. Notice that when I subtracted 9 from both sides, I got y squared. And y squared is not a function. Remember, when we want a function, we're not going to have squares with the y here. And that's because this originally was not a function. Okay, and y squared is actually a parabola on its side like this. That's why we have this plus or minus, because the positive part corresponds to this part of the parabola, and then the negative part corresponds to this part of the parabola. Because if you think about it, if we just take the positive, we have a square root function, the square root of x minus 9, and the square root function looks like this. And the negative on the outside is flipping that square root function upside down. Now we know what the graph of this, the function that's the inverse of this one looks like. You can see it's this one right here. Now, like I mentioned, this y squared actually looks like this, but we're going to get rid of a portion of this graph, and we're going to get rid of this bottom one because there's nothing over here. So we're just going to take the positive part of this square root. So the inverse function is going to be f of x, f inverse of x, is equal to this square root x minus 9. Again, we're taking the positive part. And this is the square root of x, which looks like this, shifted to the right 9 units because we're putting that 9 inside that square root here. Okay, so we can see the graphs, and we have the equations of the function and its inverse. Let me just put this in a little box so we can see it a little bit better. And now let's talk about the domain and the range of both of these functions. Now, we were told in the very beginning that the domain of this function is anything bigger than 0, and we can see that here in the graph. That means that the range of this function is going to be 0 to infinity, because remember, this guy's domain is the inverse's range. And to find this one's range, We don't have to look at the graph. You can if you want to. You can see the lowest number here is 9, and we go up to infinity. But all we have to do is look at this function. Notice that this bottom part, x minus 9, because we're taking the square root, that has to be greater than or equal to 0, which means x has to be greater than or equal to 9. So the domain of this function is 9 to infinity, which means that the range, so if this one is the domain, the range is 9 to infinity, because the range of this function is the domain of the inverse. So I think we solved all pieces of this problem. Okay, so we've done this one now. Let's look at one more, and I tried to choose a problem that was a little complicated. We haven't done a whole lot with fractions, so let's try that. Okay. So this is problem 62, and we're given that f of x is equal to 4 over x plus 2. Again, we want to find the inverse function. We want to find the domain and the range of both the function and its inverse, and then we want to graph both of the functions. So let's go ahead and get started here. Here's the line y is equal to x. And maybe we can go ahead and graph this. So this function kind of looks like 1 over x. And we know what that function looks like. 1 over x looks something like this. So that's the parent function. Now, how do I go from 1 over x to 4 over x plus 2? So if I call this function, let's call it f1 of x. Well, I could plug into f1, x plus 2, and I'll get 1 over x plus 2. And when we plug in x plus 2, that's the same thing as moving to the left 2 units. So if we move this to the left 2 units, first let's get a point that it goes through. 1 over x, well, that goes through 1, 1, and also through the point -1, -1. If you plug in -1 here, you'll get -1. So if we're going to shift over 2 units to the left, these points need to move over. This x coordinate is going to move over 2 units. Also, this has an asymptote at y is equal to 0, so that needs to shift over 2 units. So I'm going to go over 1, 2, and I'm going to put that asymptote here. And then I'm going to erase this. And that point, which was -1, -1 will now become 1, 2. This will become -3, -1. And the graph is going to look something like this. And this point, which was 1, 1, is now going to become 0. This is -1, 1. So we can get rid of this and draw this line here. Okay. So it's just basically the graph moved over 2 units. And then we also have this 4 here. What does that 4 do? Well, to change this function to this one, let's call this a new function. Let's call this f2 of x. This is 1 over x plus 2. Now to make this function look like this one, we just need to multiply it by 4. And that's the function we want. So it actually stretches our graph. So this point, which is now right here, this is -1, 1, because it was 1, 1 moved over 2. Now we're going to multiply that y value by 4. So 1, 2, 3, 4, that goes way up here. So we're just going to do a little editing here. This function is going to look basically the same, just kind of stretched out. So something like that. Doesn't have to be perfect. And this point, which was a -3, -1, will go to -3, -4. So somewhere down here, it's going to look something like that. So just stretch the graph, and the graph looks basically the same because when we're stretching it, we're still going to go upwards like that, and this piece is still going to head towards 0. Same thing with this. You could try to go ahead and sketch the inverse function. I think it might be a little confusing. How about we find the inverse function first before we start sketching? So let me just erase all of this. Okay, how do we find the inverse function? Well, we set this equal to y, and then we switch the roles of x and y. Now the objective is to solve for y. I have y in the denominator, and I don't like that. What I'm going to do is I'm going to multiply both sides by y plus 2. So I get x times y plus 2 is equal to 4, because if I multiply this side by y plus 2, that'll cancel. I'm almost done. Let's get rid of this x by dividing everything by x. So we get y plus 2 is 4 over x. And then I'm going to move the 2 to the other side. So y is equal to 4 over x minus 2. So this is going to be the inverse function. And the last step is just to remove that y and make it f inverse of x, because that is the inverse function. Okay, so maybe we can sketch this. Let's think about this function. This looks like the function 1 over x. I'm going to start graphing in red. So we said the function 1 over x looks something like this. And then what we do to get this one is we need to multiply it by 4, which is the same thing as stretching like we did here. So I'm going to stretch it like that. And then we're going to move the graph down 2 units. So this asymptote, which is, I think I called this one y is equal to 0. That's actually x is equal to 0. This asymptote is y is equal to 0, and that's moved down too, so it's moved to here. Which means that this line here is going to be moved down 2 units as well. So what we're going to get is something very similar, just like this, and then move this graph down. So something like that. So let's think about this. Does this look like the inverse function? So this piece here, remember we're reflecting it across this line. So this piece has been reflected to this piece. Of course, this is a sketch, so it's not completely, you can see I have too much space here compared to this space. But you do see that this asymptote, this straight line, is 2 units away, and so is this one. And then this piece here, which is going toward this line, is now this piece going towards this line. And then this piece is reflected here. So it is the inverse. So we have graphed the inverse. Now let's talk about the domain and the range. And again, I'm not going to look at this graph to figure them out. I'm just going to look at the functions. So let me erase all of this. In fact, I'm going to go like this. And then I'm going to move this piece over to here because that's the inverse. Now let's find the domain and the range. Okay, looking at this function, you can tell the domain because we have a fraction, and the only problem with the fraction is we can't plug in -2. So the domain is all values except for -2. Now look at this function. Where do we have a problem in the domain? Well, we can't plug 0 into this denominator, so we got to take that number out. Now, the range. Looking at this function, just looking at the equation, I can't tell what the range is, but I do know that it's equal to the domain of its inverse. So this is -infinity to 0, 0 to infinity. And looking at this function, I can't tell the range just by looking at it, but I know it's the domain of the original function. So this is -infinity to -2, then -2 to infinity. And you can check with this graph. So with the green graph here, which goes with this white function, you can see that I had to take -2 out of the domain, which is right, because here's -2. So we have this asymptote here. And also the range, you can see that we don't go below, on this part of the graph doesn't go below this asymptote here, and this one doesn't go above, so we had to take out 0. Just like we got down here with the domain and the range. And for the domain of this one, you can see we had to take out for the red graph, we took out 0 because this is an asymptote. And here we have an asymptote at -2. So we took that out of the range.